This is Euclid Book 7, proposition number 29, and what I'm going to do is I'm going to show you the diagram first. This one is going to be incredibly simple. Okay. Let's get into this, shall we? Any prime number is prime to any number which it does not measure. Okay. Let A be a prime number. In this case, we're going to let A be 5. And let it not measure B. Well, obviously, 5 does not measure 8. I say that B and A are prime to each other. Well, we can say that automatically, but let's prove it. For if B and A are not prime to one another, which in this case they are, we could change that 5 to say like a 4, 1 or 2. Some number will measure them. Okay. So let's say that 5 is actually a 4. Well, obviously there is a number that will measure both 4 and 8. And we're going to say that that number is C, and we're going to say the C is 4. Since C measures B, which of course 4 measures 8, and A does not measure B, which if we leave it as 5, of course 5 does not measure 8, therefore C is not the same with A, which means that 4 and 5 are not the same number. Now since C measures B and A, therefore it also measures A, which is prime. Well, if C somehow measures A, which 4 does not measure 5, but let's say it did, then the 4 and the 5 would have to be the same number, and of course A being 5, that's not the same number, so therefore this is impossible. You can't have 4 and 5 being the same number and 5 being a prime. They don't work that way. Therefore, no number will measure B and A. There's no number that will measure both 8 and 5. Therefore, A and B are prime to one another. And that's the whole proof. You like that one? Alright. I will tell you more in a future video. Stay tuned.